So what are the challenges trying to run a test inside of a CT scanner? Well, the first thing that comes to mind is that you want to try to maximize the resolution. Um, Secondly, you got to be careful that you have no out-of-plane motion during the mechanical test, because that can affect alignment, it can affect the scan quality, and if you're using digital volume correlation, it can impart false strains. Next, you want to make it so that it's easy to mount samples. And finally, and something that's not quite as often considered, is you want the same mechanical load frame to be able to handle different force capacities. Whereas when you try to swap out load cells, it can be challenging to realign the entire system. To maximize spatial resolution, the source needs to be placed close to the sample. But if you have a load frame with two support posts, and you try to rotate the entire load frame during the CT scan, then the support posts are going to get in the way of the source. And so the way around this is to have a rotating load train. An alternative to the rotating load train is to have a tubular support structure instead of two support posts. Now, there's a few problems with this, in that tube, no matter how hard you try, will block some of the x-rays, which is probably fine if you're scanning metals, but if your scan is actually a polymer and the tube is also a polymer, can be problematic. The second problem is that in order to have a tube support structure, the specimen loading is tricky. You literally must dismantle the entire load frame to mount the sample, and that can get complicated, especially for higher force type of samples. And finally, because of the tubular support structure, the source can never be very close to the sample. This is why the rotating load train is a better solution. The next thing to consider is out-of-plane motion, and this in fact is where Psylotech load frames excel. Our load frames were actually designed after the advent of DIC, and actually after DIC became more mainstream. And as such, we've done a number of things to minimize out-of-plane motion on our normal under microscope load frames. So one of the key aspects of this is that there's a rotating nut, a translating screw, and that nut is the servo motor's rotor. And there's a minimum number of moving parts, which limits the amount of out-of-plane motion. And because there's no gearbox, there's no associated off-axis loads or twisting loads that can come from the forces associated with belts or gears. Now you can see that rotating nut caused the screw to translate. In the case of a rotating load train, the really only big difference is that there's a second servo drive. Instead of having the moving crosshead be on rails, linear rails, there's a second servo drive that controls the rotation of the screw. So in the rotating load train system, we control the rotation of the screw and the nut to very high precision, and as such we're able to rotate the load train. And so how good is the alignment? Well, consider this sample that's been mounted in an xTS, and note the long extension. During the full 360-degree rotation of the rigid body rotation, you can see by the dial indicator gauge that there's very little motion out of plane. And I want to clarify also that this sample is not a perfect diameter. It's a little bit ovalized. In fact, the amount of aberration you see from the dial indicator is pretty comparable to the variation in the sample. Psylotech's xTS also takes advantage of our high-resolution load cell technology. These sensors implement a capacitive Wheatstone bridge instead of a resistive Wheatstone bridge from a strain gauge transducer, and as such they have 400 millivolt per volt sensitivity. And with so much more signal and a similar signal-to-noise ratio, we can actually resolve about 100 times better measurement than a strain gauge alternative. We have these for axial load cells, so tension and compression, but also for an optional torsion sensor. Now the advantage of this is with the same system and the same configuration, without having to realign anything, you can run a test that has a peak load, for example, of 10 kilonewton, or with the same setup, a test that has a peak load of 100 newton. In other words, where you would normally use a 100 newton load cell. The other nice thing about this approach is that there's no rotating connector. We actually hang the rotating actuator off of the load cell because it's capable of handling that load. And the benefit of that is that there is no rotating connector to worry about, and the associated noise and potential failure point is eliminated. Psylotech offers a range of micro CT compatible universal testing frames. We have capacities as low as 100 newtons all the way up to 45 kilonewtons, though the fundamental technology could be expanded, so please let us know if you would like higher or lower, frankly. There's a torsion option. We can go up to 300 newton meters of torque. We could potentially put a temperature chamber around the system, although it is tricky to get liquid nitrogen and air into the CT scanner. But this is possible if we can sort out those issues for you and your specific CT scanner. And then we also provide integration and automation services. Automation so that you don't have to sit around for all the number of points in the stress strain curve when each of these CT scans can take on the order of an hour. And yes, that is me, Alex Arzumanidis, very excited to have our first CT scan compatible load frame inside of a CT scanner. In this case, it's a Nikon CT scanner at the University of Texas at Dallas. And to summarize what we talked about today, there's a rotating load train which maximizes resolution, and our actuator technology allows for very low out-of-plane motion and also facilitates sample mounting when compared to a tubular support structure alternative. We offer multiple force scales with our high-resolution load cell technology, both for force and for torque, which makes it easier to run a broader range of samples. And we can also offer torque. Thank you very much for your attention today.